Okay, this is 9.5, our vertex form quadratic function review. For the first few problems, we're just going to graph these functions and then label the vertex, the direction of opening, the axis of symmetry, and the zeros. Let's take a look at number 1. Remember that the vertex of this guy is always going to be the opposite value of h and then the k. In other words, our vertex is always coming from our vertex form, which is y equals a x minus h quantity squared plus k. If I steal the h value and the k value, that will give me my vertex points. However, to get my vertex all together, I need to change the sign of the h. So it's really like that. So we switch the sign on the h alone, and then it's really easy to find the vertex, just the number with x and the number outside. So keeping that idea in mind, my vertex of number 1 would be this value for h, except I'm going to switch the sign, so that's going to be -4, and then the value on the back for k, which is +4, and remember we don't switch that sign. So switch the sign, don't switch the sign. And here we go. We have our vertex point, so we could go ahead and graph that. If I'm at -4, +4, I'm right here on my graph. Now I'm ready to figure out where this parabola goes. I already have an idea that it's going to open down because I have a negative number out front. So this guy is going to open down, again, because the a value, or the number in front of the parenthesis, is negative. I know that this is my vertex point, so the axis of symmetry has to go right through that vertex as to this dotted line. So this is my axis of symmetry, which is at an x value of x is -4. If you notice, my axis of symmetry is the same as the x value of the vertex, or in other words, the opposite h value. Last, I need to find the zero. So this graph is going to cross the x-axis, and I'd like to know where. I haven't finished drawing my graph yet, so let's go ahead and do that and see what happens when we get close to the x-axis. To finish this graph off, we need to plug in some points. So we're going to make a little xy table here. And I'm going to plug in some points for x to see what I get for y. We're going to use the original function to do that. Instead of just picking a random point to start with for x, let's be strategic about this and pick a point that's close to the vertex. Right now, this vertex's x value is -4. I had to go -4 to get to this vertex. So let's try plugging in, say, -3, the point right next to it. I'm going to start by plugging in -3, which means I'm going to take my original function, and instead of writing x, I'm going to write -3. So that means altogether it's -3 plus 4 quantity squared plus 4. And I usually honestly just put this into my calculator, including the parentheses and everything, and see what I get. You could absolutely use your brain to solve this. Make sure you do PEMDAS, so solve the inside of the parentheses, square that, then stick a negative, and then add 4. But calculator is just as good and quite faster, actually. When I do that, when I do solve, I get 3, which means that my point here, I plugged in -3, I got 3, so it's -3, 3 is my next point that I can graph on my graph. So that's right here. And then our axis of symmetry says that there's a mirroring port on the other side there, so I kind of got a 2-for-1 deal. I got to graph 2 points, and I only had to plug in 1 value. Let's keep going. I want to keep going until I have at least 5 points. Right now I only have 3. So let's plug in a value, say over here at x is -2. So if I do my xy table, I'm again going to steal the exact same equation, but instead of writing x, I'm going to write -2. So -2 plus 4 quantity squared, and then plus 4. I plug that into my calculator, and I get 0. Which means that when I plugged in -2, I got 0, so my point is -2, 0. That means I'm right here on my graph. A mirroring point, or using the axis of symmetry, shows me I get another point over there. Now I have 5 dots on my graph, so I am allowed to go ahead and connect these dots with arrows at the end to form a really nice looking parabola. We can see now that this graph crosses the x-axis at these 2 points, which are, of course, x equals -2 and x equals -6. So those are my zeros, x equals -2 or -6. All right, let's take a look at the next one. Before we start, we can already tell that this parabola is going to open up because I have a positive a value. I also know the vertex already. It's going to be this value plus the value in the back, which you might notice there's nothing written there. What if I put a +0 on that equation? Did I change that equation at all? Okay, so there's a hiding 0 back here that represents my k value. In other words, my vertex is going to be this value of -1. Remember, we switched the sign, and then comma 0 for the number in the back there. I can go ahead and graph that. That's right here on my graph. And then I know that my axis of symmetry has to go right through that point. So I know that my axis of symmetry is going to be x equals -1. Or in other words, the same exact value from the vertex. Now for my zeros. I'm already at a 0, so I kind of think that this parabola is going to go up from here, so he might be one of those weird ones that just touches the x-axis and goes right back up. Let's plug in some values because I still need 5 points to be able to graph this guy. I'm right now at -1, so let's try plugging in 0 for x and see what happens. If I plug in 0, then my y is going to be 1/4. Instead of writing x, I'm going to put 0 plus 1 quantity squared. And if I plug that into my calculator, or if I use my brain, either way, I'm going to get 1/4 or 0.25 when I plug that in. So that means that I plugged in 0 and got 0.25. It was really, really close to the x-axis there at 0, 0.25 and at -2, 0.25. You can see I graphed those right here. Okay, let's also see what happens at x equals 1 over here. I'm going to plug in a 1. I'll do 1/4 times 1 plus 1, square that, and I get an answer of 1, which means I plugged in 1 and I got a 1, so that means this point right here. And mirroring on the other side. You can see that as expected, this parabola is fatter than normal. There's a fraction out front, so he's going to be fat, and there he is right there. So that means that my zeros then, I only have 1 because this parabola only crosses the y-axis in one spot at x equals -1. So this is, of course, a double root, meaning that this guy crosses only one time in one spot and then just goes right back up. Let's take a look at number 3. I can tell you right now that this guy opens up because he's positive out front, and he's going to be a little bit skinnier than usual because I have a whole number 2 out front. I can also tell you that the vertex is going to be -1 from this value and then -8 from the back value. -1, -8, and he opens up. I know that that point then can be graphed right here, and that the axis of symmetry has to go right through that point. So that means that the axis of symmetry has to be x equals -1. Now let's go ahead and plug in some values and see where this graph leads us. Right now we're at the x value, x equals -1. So let's see when we plug in, say, 1 and +1 and 0. So let's see where this parabola goes as he goes off to the right. If I take my x and I plug in, say, 0, that means I'm going to have 2 times 0 plus 1 quantity squared minus 8 for my y. Either use your calculator or your brain to see that this reduces to -6. So that means I plugged in 0, I got -6, so I can graph that point right here. That means his mirroring partner would also be at -6 on the other side of the axis of symmetry. Let's next plug in and see what happens at x equals 1. So 2 times 1 plus 1 squared minus 8. If I use my brain or my calculator, I get a 0 there. I plugged in 1, I got 0. So I am right here on my graph, which means I'm right here on the other side. There's my 5 points. I can go ahead and connect the dots, and I can see that I have two x-intercepts or 0, so at x equals 1 or -3. On the back side, number 4 and 5 are the same type of problem, but now we're just adding an inequality. So we're going to do some shading on these questions. Okay, let's take a look at number 4. I can tell right now that my vertex is going to be +1 and +1, 1, 1. So I can graph that point right here. For the rest, I'm going to have to plug in some values, and I think I should only have to plug in 2 values, and then I will have 5 points to connect on my graph. X, Y. Let's plug in, let's figure out what happens when x is over here at 0 and x is -1, just to see what goes on over on the left-hand side. If I plug in 0, that means I'm taking 0 minus 1, and then I'm going to square that and add 1. Which is, of course, 2 altogether. So that means that I plugged in 0 and I got a 2, so that would be right here. Axis of symmetry tells me that this point would also be on the graph because they have to be symmetric on either side of the vertex. Next, let's try to see what happens at x equals -1. So I'll take -1, subtract 1, square it, and add 1. When I solve that, I get 5. Which means that I plugged in -1 and I got 5, so I can graph that point right here. And his mirroring partner on the other side of the vertex. Before connecting these dots, take a look at your inequality sign. This is a less than or equal to. Because it's or equal to, you can go ahead and connect that with a solid line. Make sure you go all the way up to the top of the graph and put some arrows on that guy. We are not done until we shade. We're going to shade this guy depending on the inequality symbol. It says the function is less than this line, so it needs to be smaller than or below. So we're ready to color below the line, so that would be anywhere below this graph and including that graph. That's why we have a solid line there. There we go. Y is less than that graph. All right, let's take a look at number 5. We're going to do the same thing, starting with the vertex. I have a -4, -2 vertex. Remember, this guy's sign changes, this guy's sign doesn't. So -4 down 2, that means my vertex is going to be right here. If you take a look, you notice that there's a negative sign out front. My parabola is going to open down and start at this point, but open down. Let's see where he goes. Let's try to plug in points that are around the vertex. So maybe -3 and -2, and see where my graph is at those points. Here's my little XY table. If I plug in -3, I get -3, or I'm sorry, -3, so there's a negative out front. I can't forget that guy. -3, and then +4 quantity squared minus 2. That will give me a -3 as well, so that means I plugged in -3 and I got -3. So if I go -3, -3, that's right here, which means his mirroring partner is right there. Let's try -2 as well. If I plug that into my calculator or use my brain, I get -2, -6. So right here, and his mirroring partner is right here. Now be very careful before you connect these dots. Notice that this is an inequality, and this is not less than or equal to, it's just less than. Therefore, I need to connect these using a dotted line. So do your best to try to connect these in a curved fashion. It's kind of hard when you're doing dotted lines, but make sure that it's dotted to signify that this graph does not include the actual line. It just gets really darn close to it. Next, we're ready to shade, and we need to shade signifying that y is less than that number. So y is below or less than this graph. So that means it must be inside of here. It has to be below this graph, so inside in this case. And there you go. All right, we're ready to move on to converting from vertex form or from standard form to vertex form. Remember that we can convert from standard form to vertex form pretty easily if we use completing the square. I'll just rewrite the problem, and instead of saying f of x, I'm just going to say y, because they're the same thing, they're interchangeable. Y equals x squared plus 8x minus 6. When we talked about completing the square, we talked about the very first step is to get the last number out of the way. So I'm going to add 6 to both sides of the equation just to move him out of the way. That means on the left-hand side, I have y plus 6 equals x squared plus 8x. The next step is to add in some blanks. We're going to fill this blank by taking the middle number here, dividing it by 2, and then squaring it. So 8 divided by 2 gives me 4. 4 squared is 16. We're going to add a 16 to the right-hand side of the equation, so we must do it to the left-hand side as well. That means after simplifying, I have y plus 22 equals x squared plus 8x plus 16. We're almost done here. The whole point of completing the square is that you just formed a perfect square trinomial. So you can factor this really simply using the perfect square trinomial shortcut. The square root of the front, which is x, the square root of the back, which is 4, and the sign of the middle, which is positive. That quantity squared equals y plus 22. We want to get y by itself now, so we're just going to stick that 22 back on the other side in the back of the parenthesis. So, all together, we have vertex form ready to go. Y by itself equals the quantity x plus 4 squared minus 22. Lots of my students forget this squared, so don't forget that when you finish this. Now that I have it in vertex form, it's very easy to see that there's no a in front, so it's not going to be negative, so it's going to open up since the number out front is positive. And the vertex is just this number and this number. Remember, we switch the sign on that 4, so it's going to be negative 4, and we leave the negative 22 alone. So negative 4 comma negative 22, and we've got the vertex. For number 7, we're going to do the same thing. Starting with y equals x squared minus 6x minus 1. The very first thing we need to do is add that 1, get rid of that 1, put him to the other side. That leaves me with y plus 1 equals x squared minus 6x. We can go ahead and add our blanks and then fill them in by taking the middle number, dividing it by 2, so that's negative 3. And then if we square that, that's positive 9. We're going to add 9 to both sides of this equation. So that means on the left-hand side, I have y plus 10, and on the right, I have x squared minus 6x plus 9. If I were to factor this side, I'm going to get the square root of the front, which is x, the square root of the back, which is 3, the sign of the middle, which in this case is negative. That quantity squared is going to equal y plus 10. Simply move that 10 back to the other side of the equation, and we have our y by itself, and we've just converted this into vertex form. Here it is. So we can put that up here. Y equals x minus 3 squared minus 10. There we go. There's my vertex form, which means I can now see out front there is no number, there is no negative, so this guy is going to open up, and then I can see that my vertex is going to be negative, not negative 3, positive 3 from here. I'm going to change that sign, positive 3, and then negative 10. Remember, when you make the vertex, you switch the sign, you keep the sign. Last but not least, let's just take a look at this graph and find the formula for the equation. I have the vertex right now at 4 comma negative 4. That's the vertex point. So if I were to plug this into y equals a times x minus h squared plus k, I'm going to plug this 4 in for h, make sure to switch the sign. I'm going to leave the negative 4 for k and leave it. The A in this class, we're really just focusing on, does this parabola open up or down? Since in this case it opens down, we need to put a negative sign for A. Again, that's because it opens down, so we need to signify that in our equation. We have then y equals negative x, and then instead of plus 4, I'm going to say minus 4, quantity squared, and then I'm just going to keep this same value, minus 4, for k. The next one, find the vertex. In this case, we go negative 4, comma 1. We're ready to plug that in. I have y equals, this guy opens positive, so the a value is just going to be positive 1. We're going to leave it as positive 1. And then x, instead of saying minus 4, I'm going to say plus 4, quantity squared, and then I need a plus 1 on the back. Again, I switch the sign for this one, I leave the sign for this one. The A out front is just deciding if it's positive or negative. So since it's positive, I left it as a positive. Whereas on number 8, I put it as a negative because it opened down.